I'm using Amazon Code Catalyst, our unified software development service for development teams to quickly build, deliver, and scale applications on AWS. Within Code Catalyst, you have an issue management, and I will use that through the demo. However, the majority will happen in my IDE. So let's look at the first task to upgrade to Java 17. As Elastic Beanstalk is retiring Java 8 support, it's important to upgrade to Java 17. So I will assign the task to me and move it to in progress. I already cloned the repository. The first thing I want to do is to get an overview of the application. Remember, I'm not familiar with the code base. So I could go through each of the classes in the source folder, or can open one file and ask Amazon Q to give me a summary. So I open Amazon Q chat, which is part of the AWS toolkit, and click Explain Selected Code. And Amazon Q will explain me the selected file. This gives me a great starting point. I will also check the POM file. And as you can see, it's compiling for Java 8, which I want to change. I will use Amazon Q code transformation feature, which I can execute with the /command transform. Amazon Q will check if my project is eligible for transformation, and then ask me which module and target code version I would transform it to. After confirming this, Amazon Q is building the project locally to check if no compilation errors exist, and then it will upload the code to a secure build environment. The transformation is an iterative process which will be outlined in a transformation plan. It will then execute this plan and fix eventual issues on the way. Once the transformation is done, Amazon Q will give me a summary of the changes. And I can also view the diff of the files. Here you can see that it successfully upgraded the code. And in the POM file, you can see that it upgraded to Java 17. This looks all good, and I can accept those changes. Before we push the changes, let's make sure we can build the project locally. All looks good, so let's commit and push the changes. Let's also make sure the changes are visible in Code Catalyst in our repository. All looks good, so we can go to our issue management and move the issue to in review. And done. The next issue is about breaking down the application into microservices. This is a complex issue, so I think it's a good idea to break it down into tasks. I can use Amazon Q to recommend tasks for me. This is a very powerful feature as it helps me to plan my work accordingly. Here you can see the recommended tasks. First, refactor monolith to separate flight specials and hotel specials services. Then deploy flight specials service on AWS Lambda. After that, deploy hotel specials service on AWS Lambda. And then finally, decommission the monolithic application on Elastic Beanstalk. Those tasks look great, so let's create them. Once they are created, I assign the parent task to myself and make sure the order is correct. Let's look at the first task, refactor monolith to separate flight specials and hotel specials service. We can follow those instructions and implement it ourselves, or we use the help of Amazon Q in our IDE. Let's switch back to the IDE. Let's open Amazon Q chat again, and this time I'm using the /command def, and I will just paste the description from the issue. Amazon Q will now create a plan on how to implement the feature, which will take a moment. Once the plan is generated, Amazon Q will outline the plan in the chat panel. As you can see, the plan is quite detailed. It will describe which classes to refactor, which microservices to create, and also to make the code work with AWS Lambda. It also highlights to add some tests and implement error handling and logging. I could now give feedback or ask Amazon Q to generate the code changes for me. So let's do that. What happens now is that Amazon Q is uploading the code for processing and then create a patch file with the changes. Here you can see the outline of the patch file, which I can now review. On the first view, it doesn't really look as the microservices are implemented correctly, as I can see only changes in the flight specials request handler and in the controller. Let's look at the Java class in detail. This doesn't look correct, as two classes are implemented in the same file. Also, the POM is not what I expected, and the index controller and index JSP don't look good for me either. What I can do now is to provide feedback to Amazon Q on how to improve the code. I would like to have the services in separate classes, and the POM should generate 2 jars. Amazon Q will now generate the code again according to my input. This time it looks already better in the overview. So let's review the code. The POM XML references 2 modules, and the flight specials and hotel specials request handler are separated into their own modules with their own POM files. This time it looks great as a starting point, so I can accept the code changes and close the chat session. Let's look at the project again. And as you can see, Amazon Q didn't remove any of the existing code from the monolith, which is good in my opinion. But that means I need to clean up a bit before I can close the issue. Back in our issue management, I already closed the microservice issue. Now I want to work on the CDK capabilities. The description says that each microservice should be deployable via CDK in TypeScript. So let me copy the description and go back to our cleaned up code in the IDE. I will open up Amazon Q Chat and use the same /dev feature and paste the description of the issue. Again, Amazon Q will generate a plan. And I can generate the source code. As you can see, it generated CDK code in TypeScript for me, which shows that Amazon Q can generate code in several languages. Let's review the code. It has a stack for each microservice in its own TypeScript file. And it has a CDK app which references those stacks. It also has some unit tests. This looks like a typical skeleton, so let's accept it. Let's make sure the files are updated in our project. Although the code is not complete, it gives me a good foundation. I implemented the rest of the code so I can deploy the microservices with the CDK, and I also restructured the project to my liking. You can see all is implemented, and I can now deploy the flight specialist stack, which takes a moment. And I will do the same with the hotel specialist stack. Let's also look at the AWS console that both services are deployed correctly. Here is the flight specialist stack, and you can see all the resources it deploys. Additionally, here on the Lambda console, you can see the runtime, which is Java 17. Great. Now we have all our issues resolved. However, what if we want to add a new feature? So let's create a new feature issue. We give it a title. And a description. This time, I assign it to Amazon Q and give the necessary permissions to it. What will happen now is Amazon Q will start to work on the task, and once it's in progress, you can follow the updates. It will first create a background about the existing application, which you can see here. Then Amazon Q will evaluate the complexity. The task seems complex for Amazon Q, and it suggests to create subtasks similar as before. For this time, I will continue without creating extra tasks, which causes Amazon Q to create a new approach. Once this is done, I can review the approach and give feedback similar to what I did in the IDE. I can then proceed with the implementation. After clicking Proceed, Amazon Q will generate the code and create a pull request for me to review. You can see the pull request was created, and I can review it right in Code Catalyst. Amazon Q implemented the CDK part of the microservice. And I can approve and merge the pull request. Of course, there are some additional steps to take, but as I chose to not create separate tasks, it was a simplified implementation. This is amazing. I just implemented the deployment scripts for a new microservice without even opening the code in the IDE myself.